function notation is a way to indicate an equation is a function. So remember, we've been looking at relations and functions are special relations where each x value has one y value. And if an x value has two different y values, then it's no longer a function. So the equation 3x minus 5, pick an x value, any x value. Say a number. 2. If x is 2, then we would have 3 times 2 minus 5, which is 1. So that means when x is 2, y is 1. If you plug in 2 again, will you get a different answer for y? No, you shouldn't. If you start to get different answers for y, then you have other math problems that we'll work on and we'll get better at. But every time you plug in 2 for x, you should get 1 for y. What happens if we pick another number? What if we pick 5? Will we get more than one answer? Or we should always get the same answer. So this equation is a function. Yes? We are on page 11. So to indicate that this is a function, instead of writing y equals, we can write f of x equals. And basically the idea is that f of x is the same as writing y. It's just function notation instead of other notation with a y value. So f of x is saying that it's a function, it depends on the value of x, and so we're just learning a new notation, but the easiest way to think about it is that f of x is just another way of writing y. So instead of using y, this uses two variables, f of x, and it means the same thing as y. Okay, so how do we say it? We say f of x. Most often function notation uses the letter f to start with, probably because function starts with the letter f. And then if you used up one letter and you want to use a different one, then after f comes g and then h and so on. So we have function notation can have any letter in front if you want to. The letter inside the bracket has to match whatever letter's on the other side of the equation. So these are examples of functions. And if you think about each of those equations, if you plug in an x value, you will always get the same y value. So function notation is helpful because we can have questions like this. If f of x equals negative 3x plus y, evaluate f of negative 2. In your old notation, this question would look like this. If y equaled negative 3x plus 9, find y when x is negative 2, or when x equals negative 2. Those questions mean the exact same thing. Okay? Oh, I should want to really make it the same. I should use the same words. So I'm going to go evaluate y when x is equal to negative 2. So some nice things about function notation is this question was written a little bit shorter, right? This f of negative 2 replaced all of that. So it was written a little bit shorter. So that's an advantage, that function notation, we can say a lot with the notation. F of negative 2 is telling us what is the y value when x is negative 2. And how do we solve that? Well, we solve that by saying f of negative 2 equals negative 3. We plug in negative 2 where the x is. Negative 3 times negative 2 is positive 6 plus 9 is 15. So here are a couple for you to try. If g of x equals 3x squared minus 1, find out what g of negative 2 is, and find out what g of 5 is. There's something I want you to be careful with both a and b, so I want you to try them first on your own, because if you're going to make a common math mistake, it's good to make it, and then to become aware of it, and then figure out what did I do wrong. G of negative 2. This is saying, can you find the y value when x is negative 2? And so our notation, we can write it, g of negative 2, all that happens is now the x, right? If I highlight some stuff here, here I have an x inside and there I have an x. So now if I have a negative 2 inside, I replace wherever I had x's with negative 2's. And now it goes back to a order of operations, maybe grade 8 mental math question. What do we do first? We do our exponent first. Negative 2 squared is 4. What does this mean when the 3 is outside the brackets? Adding, subtracting, multiplying, or guessing? Multiplying, good. 3 times 4 is 12. 12 minus 1, the answer to this one would be 11. I would love that. They should invent a mathematical symbol which just means guess. And you can't get it wrong if you guess, because whatever your guesses would be right. That would be a very, we should invent that, the guess symbol. G of 5. So G of 5 means wherever there was an x, we put brackets and replace it with a 5. The reason the brackets are important when you substitute a value in is so that you keep things together. Like here, the negative 2 is getting squared. And the number one mistake in the first one is people write negative 4. Okay? You have to be careful on your calculator too, because if you go to your calculator and you type negative 2 squared like that, it will give you the wrong, well, it's the right answer, but it's the wrong answer you were looking for. Because your calculator also knows order of operations. And it does 2 squared times by a negative 1. If I have the brackets there, it is something totally different. Then it's going to be positive 4, which it should be. So now order of operations, 5 squared is 25. 3 times 25 is 75 minus 1, 74. Okay. Now we have two functions. We have a function g of x and a function h of x. So when we want to find g of negative 1, we want to plug in negative 1 in for x into the g of x function, because it's asking for g of negative 1. When we have h of 3 halves, we're going to have to work with our fractions. Okay? And we would plug that 3 halves into h of x. And in the third one, you have g of 1 and h of 2, so you have to plug 1 into g of x, the other one into h of x, and subtract the 2 answers that you get. Okay? So I'd like you to try all 3 on your own, and then in part C, we're going to talk about how we can show our work and write our notation so that we don't make mistakes in the end. All right, let's see how you did. G of negative 1. is equal to. Now, wherever there's an x, it gets replaced with a negative 1. So there's x's in two different places, so each of the x's gets replaced with a negative 1. Order of operations, you would do the squaring first, so this will be 3 times positive 1. Minus a negative is same as adding 1 plus 7. 3 plus 1 plus 7 is equal to 11. For the second one, h of 3 halves. That means in h of x, every x gets replaced with 3 halves. So you'll have 2 times 3 halves minus 1. How do you multiply fractions? Well, this would be like 2 over 1. You multiply your numerators and you multiply your denominators. Okay? I also want you to notice that if you were multiplying 3 times 2 and then dividing by 2 afterwards, does it make sense that these 2's will just simplify away? 2 divided by 2 is 1. You could do that first, and then that just becomes 3 minus 1, so the final answer for this one would be 2. For the last one, there's sort of 2 different ways you could do your notation for this one. You could figure out g of 1 separately. G of 1 would be 3 times 1 squared minus 1 plus 7, which is equal to 9. And then you could figure out h of 2 separately. H of 2 would be 2 times 2 minus 1, which would be 3. And once you found each of those separately, you could now say that g of 1 minus h of 2 is equal to 9 minus 3, which is equal to 6. This is nice to do separately that way, and this is how you would show your work neat and clearly. What did I do? First, I figured out g of 1 and found out that was 9. Then I figured out h of 2 and found out that's 3. And finally, I subtracted them. Now, sometimes people like to do it all at once. So if you started with this and said, this means I have to plug this into g of 1. So you would have 3 times 1 squared minus 1 plus 7. Subtract h of 2, and I'm going to make a little mistake here, 2 times 2 minus 1. Now, the danger of doing it all at once, okay? The danger of doing this all at once is if I multiplied this out and figured things out, I'm going to get, in this case, 4 instead of 6. A little small mistake. One of the things that is important is if you're figuring out g of 1, put that in an extra set of brackets to say I want to figure that out first. And then put h of 2 in another set of brackets. That will, if you figure out the green first, that will give you, and I'll keep the brackets, we know that that's going to be 9. Keep the brackets green. Minus, and we know that this is going to be 3. And then you would get 9 minus 3, which is 6. Without the brackets there, can you see that in here you would have minus 4 and then minus 1 again, which would end up subtracting 5 instead of subtracting 3. So sometimes doing it all at once can cause you to have some problems with your notation, and maybe it makes sense to evaluate each one separately and then put them together. Example 4. The table represents the costs in dollars of buying a certain number of bus tickets. How much are bus tickets now? They're more, aren't they?
Yeah, they're like $2.
$2. $2.50. Just keeps normal people. So if you look funny, you get on for cheaper?
Yeah, exactly.
Oh, okay.
That's where it's not way to get cheaper.
Oh, students not looking funny. Okay. Oh, I haven't taken a bus for a long time. Why is this relation also a function? Each x value has only one y value. If there was an x value that had two y values, that would be like 4 tickets cost $7, 5 tickets cost $7. Well, who would buy 4 tickets then? You would?
A long way to go.
Identify the independent and the dependent. Every time you have a table of values, your independent will be what's first, and your dependent will be what's listed second. Give the domain and range. Our x values, or independent values, are 1, 2, 3, 4, and 5. Our range, $1.75, $3.50, $5.25, $7, and $8.75. Write this function in function notation. So we need to write it in function notation. We always have our y values first. In this case, I'm going to use the letter C. Why would I use the letter C? For cost. So often in function notation, we choose a letter that's appropriate to the kind of thing that we're looking at. How much is your cost going to be dependent on how many tickets you sell? $1.75 times by however many tickets you have. Does that make sense? Now, of course, our domain is just up to 5 tickets. We don't know if they have a special after that or whatnot, but it's up to 5 tickets. Okay? Our function, you know, only works for whole numbers. Ever gone to buy bus tickets and say, I'd like to have 3.5 tickets, please? Why? Because one time I'd like to only go halfway home and walk the rest, so I'd like to pay only half the price. I don't know if that would work, but you could try. Explain what C of 100 means in words. What would that mean? The cost to buy 100 tickets. Calculate C of 100. C of 100 equals 1.7. We replace that with 100. $175. What does C of n equals 5,000 mean in words? Okay. What is the C is C of something equals, this means
That's the cost of all of those.
the cost. The cost to buy how many tickets? The cost to buy n tickets. is $5,000. That is an N. How many tickets could you buy? You figured it out? What did you do?
I divided 5,000 by 1.75.
We know that each ticket, so here is the idea. C of N would be $1.75 times N. It's just the same as C is X equals 1.75 times X. We can also change the variable that we put into our function. And what do we know that this equals to? This equals $5,000 has to equal $1.75 times N. In other words, if each ticket costs $1.75 and we spent $5,000, we could figure out what N is by dividing both sides of our equation by 1.75. And what's the answer?
2,857. There's a small decimal, but since we're talking
2,850. Well, let's see what the small decimal is. 1.428. If you spent $5,000, you could buy 2,857 tickets. That's a lot of bus tickets. You could entertain yourself for like a couple of years with bus rides. Take all the different routes in Winnipeg. Wow.
sounds like a plan.
You know how exciting that would be? Ooh, I've never seen that building in Winnipeg before.
Wow, for the coffee street.
This is our last example. The equation V equals negative 0.08 D plus 50 represents the volume of gas, V, remaining in liters after a vehicle has driven D kilometers. The gas tank must be empty before refilling the tank. Usually that's not a good strategy, right? Don't, because you're not usually right beside a gas station when it runs out. It's only happened to me once.
What, really?
Yeah.
That's just missing.
Write this equation in function notation. So in function notation, it looks the same except we put those brackets. That volume is a function of distance. Independent here, those would be your x values. Usually we have y and x, so x in this case is d, is our distance. And the dependent is your volume. Your volume depends on the distance that you drive. Find the value of V of 600. So V of 600 means, how many kilometers have you driven? 600 kilometers. Negative 0.08, plug in the 600 there, plus 50. 600 times 0.08 is negative 48, plus 50. You would have 2 liters left. At which case you should probably find a gas station fairly soon. Determine the value of D when the volume is equal to 26. So one of the things we can write out, if I rewrite out our formula, our in-function notation, we want to find the distance, And this is the thing that sometimes students have trouble with function notation. That even though v of d has 2 letters in it, it means one thing. It's just your y value, right? If they said y equals 26 and this was a y, you'd be like, oh, I replace y with 26. But somehow, since there's 2 letters there, sometimes that gets people confused. But it still means one thing. It means one thing with a lot of information. The volume at d kilometers is 26. So now we have to do our mathematics and solving equations from grade 9, right? What you do to one side of the equation, you do to the other. We want to get d by itself. So one of the things you did in grade 9 is if you had any like terms, can you see like the 50 and the 26 are like terms? They can be put together if they're on the same side of the equation. So I might start by subtracting 50 on both sides, because then I could put those like terms together. I would have negative 24 equals negative 0.08 d. And now if I want to get d by itself, the opposite of multiplying by negative 0.08 would be to divide both sides by negative 0.08. And we should add our units in the end. The distance would be, can someone check mental math there that I didn't make a mistake? 24 divided by 0.08. It's good? Awesome. The distance would be 300 kilometers.